Hello, I'm Dylan Storing O'Dowd. I work on the Camtasia team here at TechSmith, and I'm going to share out what I've learned while doing automated UI tests for Camtasia. A little background for myself: I graduated from Michigan State University. I took 3 years of computer science and then switched over to media and information to finish out my degree, and I've been working here at Camtasia for just over a year. It was the 3 years of computer science that was part of the selection of me looking into automated UI tests for Camtasia. So today, the layout of the talk is going to start with going over the testing pyramid. Then I'm going to go into coded versus record and play automated UI tests. Some of the reasons we chose to automate some UI tests, along with some reasons that I found online that might not immediately be obvious as benefits to automated UI tests. WinApp Driver is the tool that we chose, and I'll go over a quick overview of what that is and why we chose it. I'll do a short live demo on a simple UI test for Microsoft's calculator, and then I'll finish out with some tips and tricks that I learned through trial and error writing the UI tests. So this is a basic testing pyramid. At the bottom, we start with unit tests, which are small tests that test small parts of the code, like methods and functions. Next, we have integration tests, which combines the interactions between different methods, functions, and classes. And at the up at the top, we have end-to-end tests, which test full workflows of your product, and that's where UI tests sit up at the top. So it's a pyramid because at the bottom is the biggest part, because you want to have a lot of unit tests because they run very quickly and they only cover a small part of your code. A little fewer integration tests, and the smallest amount of UI tests because they often take, because as you go up the test pyramid, runtime increases. You can run a lot of unit tests in the same amount of time you could run a single automated UI test. As you go up, flakiness also increases. Unit tests are normally very solid and a good representation, pass-fail, of whether or not those small parts are working. But also as you go up, you get closer to how an actual user is going to be using your application. So that's one of the really strong benefits of automated UI tests. Besides manually testing, it's closest to how an actual user would use your application. So to get into coded versus record and play tools are normally where you would start recording and you would manually go through your workflow that you want to. The tool would record it and then create an automated test for you. These can seem really good at the beginning because it seems so simple. You just record yourself and then you play. But there's a lot of flaw in them, in that if your UI is changing often, these tests can break really easily. So you'll either have to re-record them or go in and manually change the tests that they created for you. Which, if you're going to go in there and change the code anyways, you might as well start with coded UI tests. And some benefits of that is they're slightly more solid because it doesn't rely on UI elements being in the same location, because you allow the code to find it using different names and IDs wherever it would be in your UI. Also, it's easier to get developer help because they don't have to learn a new tool. You can often, like for example, we use Visual Studio to both write our Windows application, and that's also what I use to write the UI test, so it's very easy to ask them for help and there's no build-up learning a new tool. One of the first reasons that I particularly like automated UI tests is that you can take easy, tedious tests that you have to run constantly and often, and you can automate them, allowing you to get that time back that you would spend doing those tedious tests that don't really require, they require a lot of time, but they're not a lot of work or brain power. and you can put that time back into doing more in-depth, complicated scenarios for your testing, also doing more exploratory testing, trying to find those deeper, more complicated bugs that you might not have had time to find later if you were using time doing the repeated tedious tests. Another reason is that you can have constant checking of the core features of your application. These are the features that are in all or most of your workflows of your application and need to always be working. So you can have constant checks on them, especially if you do what we have chosen to do and run them nightly. We have an automated testing lab here at TechSmith that every night at 2 a.m. we start up the machine and we run our suite of automated UI tests, and then in the morning it's reported to our messaging system telling us what systems it failed on, what it passed on, allowing us to go in and debug and figure out why it was broken so that we can have quick turnaround figuring out bugs that are affecting our common use functionality. Also most codes have like high risk areas. Like here, I know Camtasia is an older product, so I've heard developers oftentimes talk about the areas of the code that they don't want to touch because they don't really know that code very well, and it's old and might not fit the standards that we have now. And I've learned that a lot of this older code can touch parts of your product that you might not initially think that they touch. So having that suite of UI tests going around all your basic functions can give you more confidence that when this older code is touched, it's not having unknown repercussions on these other basic features. And you can catch if those changes in that riskier code had accidental breaking on the other features. Going back to using our automated test lab as an example, we have a slew of users that range on computers that can be weaker to very high-end machines. So it helps running in the ATL lab that we can check on a group of machines at night, ranging from weak to strong, so we can have comparisons, making sure that our product runs on the low-end machines and the high-end machines. If you have, for example, a web-based application or website, a lot of automated testing tools allow you to run on different browsers, Chrome, Firefox, Internet Explorer, so that you can compare them and make sure it works on all of them automatically and you're not constantly repeating it for each browser. You can also try different setups with multiple monitors, different hardware, and like Camtasia is on both Mac and Windows. Right now we don't have UI tests for Mac, but that would be a strong place to go in the future, and we can double check that the functionality works on both the same way. So we chose WinAppDriver because we use WPF to make our applications, and WinAppDriver is developed by Microsoft, so it met our needs very well. And it's supported by Microsoft and free to use. That's another big standing point. A lot of tools can cost money, but WinAppDriver is free to use. It is a service that allows for Selenium and Appium to be translated to automating Windows applications. Selenium and Appium being a tool that's used for web applications. It runs on UWP, WinForms WPF, and Win32 applications, and it only runs on Windows 10. All right, so now I'm going to quickly program a simple UI test for Microsoft's calculator explaining each of the basic parts in the UI test. Can everyone read that? Okay. So I have, so normally I would just start a new C# test, but there's a couple things that I grabbed for this example to start off with. First I have the URL that WinAppDriver uses to communicate and run the program that you're writing, and then the app ID for the calculator, because Microsoft has this ID with a bunch of random letters and numbers, and it didn't seem practical to remember that. So the first part of the test that we want to do is opening up the application. So we're going to create a setup method, and the point of this method is just going to be to start up our application, and we're going to connect it or set it to this Windows driver, and that's what's going to allow us to find different buttons and other interactive parts of the UI and start interacting with them. So this is desired capabilities is where we're going to set the app that we're opening and the device that we're opening it on. So first we want to set, oh, that's wrong. So first we want to set what app we're using, and for that we're going to use the calculator app ID that I had defined up here at the top. Instead of this app ID like they use in Camtasia, we just have the path to the actual exe of our application that's installed on the machine. So that is how, if you were using your Windows application, you would find it by using the location of the exe. Next, we have to set what device we're running it on. So we're going to set the device name, and this is going to be a Windows PC. And since looking it up on this desired capabilities is actually a class of Selenium that is going to be translated using WinAppDriver to be able to do a Windows application. And a lot of these desired capabilities, if you are doing a web-based automation testing, they have predefined desired capabilities for all the different browsers. So we just have to set this ourselves because we're doing a Windows application. For the next thing, we're going to actually we're going to set this Windows driver up here, which will open up the application and then set it there and allowing us to interact with it. So for this, we need to create a new Windows driver. And we're going to pass in the URL that WinAppDriver gave us so that they can communicate, and the desired capabilities that we gave it so it knows what application to open. So that's our setup. It's just 4 lines that basically just go down to starting the application for you. So now that we started up, we also want to close it when we're done. So we're going to create a teardown method. And this one's a little simpler. First, we want to check to see that we do have a calculator already open. So we're going to make sure that it's not null. We want to make sure it's not null, which just means that there is something assigned to it. And if it's not, we're going to grab our session. Oh, is that right? Yep, sorry. We're going to do quit, which just closes the application if it's open. And then we're going to set it equal to null, which will allow us to, for our next test, open up a new calculator. If we were going to do multiple tests, open up a new calculator and set it again. So now we have starting up the application and turning it off. Next, we would do a test initialize method. This just tells us what we're going to run at the beginning of every test. And in here, we're going to run our setup method for starting the application. And we're also going to find, what's up here, this Windows element, which is like an aspect of the UI. And we're finding calculator result, which is just this text box here that's showing the result after you do addition or something. And we're going to find that because we need to be able to find the result to check to make sure that the math actually put the result up there. So we're going to do that by setting calculator result, the window element, equal to, we got to grab our calculator session, and then we're going to find an element. And this just searches the specified application's UI for an element with a given accessibility ID. And Microsoft gave the calculator the calculator's result pad, the automation ID of calculator results, if I can spell it right. So that will just find the result text box so that we can grab the number once we're done. So that's our startup at the beginning of every test. Now we have to do our teardown after each test, and that's going to be our cleanup. And in here, we're just going to call our teardown to make. Now we have our startup and our teardown. The one last thing we're going to get, one last method we're going to get before writing the actual test is that we found the element for the actual display, but we need to actually get the text, be able to get the text out of it to get whatever number is shown in there. So we're going to create a method that returns a string. And we'll call it get calculator result text. And for this return, we're going to get our calculator result, which is the window itself, and then we're going to grab its text. But for when you do that and grab its text, the full text it actually gives you is display is and then the number. So we're just going to write two more things to remove that, because all we want is the number. So we're going to replace this display is with an empty string and trim off any white space that might be on the result that it gives. So finally, the last thing to do is actually write your test. So the first example that WinAppDriver gives on their GitHub page is simple 1 plus 7. So that's what we're going to do. We're going to be able to hit 1 plus 7 equals, and then make sure that 8 is what is displayed up at the top. So for this, we're going to find element. Last time we used accessibility ID, but this time we're going to use name because these buttons don't have accessibility IDs, but thankfully they have very simple names that are very literal to what they actually are. So once again, that'll find the element, but to actually do anything with it, we have to call the method .click. We'll just move the mouse to that element and click it once. And then for this, normally I wouldn't. So I'm going to call a sleep. This will just tell the code to like sit here for 1,000 milliseconds. Normally I wouldn't put this in my test, but going through this, if I don't put these in it, it runs really fast and it's not super easy to show what's going on. So we got to switch this to 1 plus 7. So now we have our buttons pressed, and the last thing to do is actually check the display and make sure that it's showing what it needs to show. So we're going to create a variable and call our get calculator result text to get the text. And then, so the result should be 8. So we start up the application before the test, tear it down after the test, and have a simple 1 plus 7 test. Now we can close that, restart WinAppDriver real quick, and fingers crossed it should pull up the calculator and do that. So 1 plus, and that's 8. And it checks, and then we have a pretty green check mark over here in our test, in our test explorer. So that was a very simple example. Obviously, when you get more in depth to running your actual application, you're going to want to. This is where developers come in handy, because you're going to want to spread out into multiple files and have it written to whatever standards your team starts using. So next up are some tips and tricks that I wish I would have known from the get-go. First off, don't rely on pixels. A lot of tools will let you move or place the mouse based on a certain number of pixels on the screen. And we did this originally in our first example. To find one button, we moved to the button next to it and moved over a certain number of pixels. But the second we tried moving this to a computer with a different resolution or a different DPI, that completely broke. So we had to figure out a different way to doing that. Next is to start each test fresh. The example that I just showed on Wikipedia or on WinAppDriver's GitHub page, they actually put the starting the application and closing the application at the beginning and end of the test in general. So they just start it once, run a bunch of tests, and then close it. And I found that can be a really big problem, because if one of your tests fails, it could put your application into a bad state, which means that it could fail all the tests after it, even if the things they're testing aren't broken. So I found it best to start it before the test and close it after, so that every test can start fresh. Another thing that I learned is to control the application's state. So for example, Camtasia has a trial mode. If you don't purchase it, you can still use it and try it. But for our tests, I'm not, except for a test about unlocking Camtasia, I'm not worried about unlocking it. So before any of my tests run, I have code to unlock it so that none of them have to worry about that. You can also, another thing is if you're testing specific features, before the test run, you can turn that feature on and then turn it off after the test if it's not needed for any of the others. Also, another thing that I've seen in a lot of examples and a lot of automated UI tests are doing that sleep that I did in the example, because sometimes after you press a button, the result of that doesn't happen immediately, so you got to wait for the application to do what it's supposed to do. And a lot of examples I've seen will press a button and then have a arbitrary static wait time of 5 or 10 seconds. And as long as that's enough, that's fine. But let's say the application took 6 seconds and you only waited 5, that means that you're probably going to get a false negative because you just didn't wait long enough for the application to do what it was supposed to do. And also, if you put too long, then you're just wasting time. Maybe the application was ready in 3, but you waited 10. So what I've found best to do is to put it in a loop. So it'll try the action, and then it'll wait. And if it can't find it, or if it'll try it, if it can't do it, it'll wait, and then it'll try again. And you can tell it to do it a specific number of times if you wanted to. And that's what I found that it's best. If it does it really fast, it'll exit the loop and not wait extra time. But if it needs that extra time, it has it. And then here's just an example of using that. I'm trying to find elements like I did in the example, but sometimes they don't pop up immediately. So I just tell it, try that, and then here's the max number of times I want to try it. Because if it's taking longer than that, either we have an error because our application is taking longer than it should, or it's just not going to pop up. Next, I would say start small and work bigger. We started with a full workflow from beginning to end, and that was good for proof of concept, but I fairly quickly learned that to keep going, I needed to shrink it back down to testing small parts of our application and make sure that those tests are solid before putting them together, because you want to make sure that you have a solid foundation before you start going crazy and doing the giant workflows through your application, because if you start doing that immediately, you're going to start quickly running into failed tests and not exactly knowing where it failed, because you don't have those smaller ones that are more specific. Also, get developer help from the very beginning. They're going to know a lot more about, they're probably going to know a lot more about programming, more specifically how different styles and coding patterns that'll allow your code to be more reusable and more solid and less likely to be flaky and broken. Also, it shares the knowledge with your developers, allowing them to, it spreads the knowledge, so if the one person who's writing the UI tests goes on vacation, if they're the only one that knows how to read them and write them, that means that, and they start all throwing red flags, no one's going to be able to debug them and see what's really going on until they get back, and that's not great. And next is publicize the results in your company. Let it be shown to people so that you're not hiding what tested and failed on your computer, only worrying about them. And this lets other people see, like, there's a bunch of red X's, why is that? And they can either go investigate it if they know how to themselves, or bring that to the attention of people who can. And this will allow for more quickly addressing these bugs and finding them and fixing them. Also, try not to force these tests. A lot of times you can figure out a way to automate a UI test, but that doesn't necessarily mean that that part of the product should. Is kind of like, just because you can doesn't mean you should. It might be too complicated of a scenario to be reliable for an automated UI test, and better left to either unit tests, integration tests, or manually testing by your software testers. All right, for the example I did and the tool that we use, I used Microsoft WinApp Driver's GitHub page. And for some of the reasons in the beginning for benefits, I read 7 Benefits of Automated GUI Testing by Alvin Alexander. Any questions?
So you had mentioned about showing the results. So can you elaborate a little bit more on that? Like, how do you show the results to your team? Do you have, are you sending out reports, emails, raising red flags? I mean, what are you doing to show the results?
So we have a in-company messaging tool that we have a messaging tool that we use to communicate with each other. We have at the end of running the tests every night, one of the automated test computers posts it to that it's Flowdoc. And it posts it to our automated testing group and to my specific Camtasia group, and it tells us how many of them passed and failed, and what machines they failed on, and a link to the build server so that we can check out the build log and see what was going on. Any other?
Got some short T-Rex arms. So I had a few questions. Do you ever find that you are trying to code something and the identifiers that you have to work with are very, very poor? And do you involve the developers in getting them to make something a little bit more identifiable so you can test it better?
I have definitely run into that problem before, and so far I've normally made it work. I've done some work into. I have asked and they have helped, but it's the way that we have some of our UI set up for certain locations. I can't add better ones, but whenever I do see that I need a better one or there isn't an identifier, that's when I talk to them and see what I can do to put one in, for sure.
Okay. Cool. Yeah, I've had that happen quite a bit, where, the code is there, everything's cool, but it's not really testable code, and so that is a big difference. How long did the tests that you have that you run overnight? How long do they take to run, approximately?
At night, I want to say they take between 20 and 35 minutes on average.
Okay.
I've had them take up to 45 minutes. But that's when I started seeing that they were taking a little too long, and that's when I got a developer's help to really find in my code itself where it was doing more work than it needed to, stuff that could be simplified.
Okay. And then I guess my last question is, I'm sure, or at least I'm hoping, that you guys do code reviews on all of this. Who does them and when, and that kind of, I guess, question.
In the beginning, it was mostly members of my team, the developers on my team reviewing it, but since then I've expanded to try and get other developers on the other pods in my team, on the Camtasia team, so that I can try and spread people looking at it, and it's been really successful, I think, because I've had other pods outside of reviewing just ask me to come over and explain them so that they can start learning about UI tests and how they work. Anything else?
So you had some IDs for, like, that you sort of asserted that Microsoft calls this button. Oh, is it not on? Sabotaged. Thank you for saving our battery. So how do you find those identifiers?
So I think it's Microsoft. Microsoft makes an application called Inspect that you can get. I can actually show it real quick. Yeah. Oh God, it's so tiny. I don't know how to make it bigger. But yeah, this is Windows. There we go. Is that better? Yep. Oh God. There. Okay, so it gives you at the top. It has your desktop, and that's just going to be the root to everything. And then it will normally have a list of the different applications that you have open on your desktop. And let's see if I can actually. All right. It's mad at me and it won't let me click on things. So you can open it up and it'll tree to all of the different elements in the current UI, and you can click on it, and this big open rectangle will have a list, and on the left column it'll tell you like the name, the automation ID and stuff like that, and then on the right it'll tell you the actual string that you would type into the code. And it's really weird. In the code you find by accessibility ID but in inspect it calls it the automation ID, but they're the same thing even though they have a different name.
You mentioned that you're running the test nightly. Is there a need to run them nightly? Are you making changes that often?
I think it's more just to be safe, but we do, some weeks more than others, we do have a lot of code that can be put into develop, and it's partially to I'm constantly improving them. Like sometimes at this point they're fairly not flaky, but I'm still like sometimes they still break just because they're broken, and that's when I need to I go in and I figure out why it's broken, look up and think about how I can make it better, and then I want them running again at night to see if the problem is fixed. I think it's more nightly for the accidental case, in case someone does accidentally have like a string from one piece of code to the another that we didn't think, like, why would that affect this other area? So it's more of just a safety net than a necessity.
So my question is automated UI test for website or mobile website? And does anyone do that here? And what type of tools have you used?
I don't
Versus
think anyone
an
at
app.
Selenium?
Yeah, we use Selenium on our side on video review, and those run every time somebody checks code in. The developers actually go through the process of running those, and they do it, like he's saying, for a safety net, which covers a lot of manual testing. Actually, it goes through a lot of processes. I think there's like 5 or 6 of them. They're actually working on doing them in parallel, so all of them go off. That speed build times up a lot. But on the mobile side, Appium is a good tool. Like he was saying, Selenium, Appium, same type of code base, but that's more towards doing mobile. You can do it on emulators, simulators, or actual devices, and it works for installing actual applications or doing web-based stuff. Well, no, Appium's like a server, like, so you're writing the code there, and it can test applications you'd install from like the App Store or something. But it also does like you could open up Chrome on mobile, and that'll work too, same way, yeah. And Sauce Labs is the tool that they use to try to grab every single browser, so it pulls up all the browsers, and then it'll run all those tests. So every time that there's a check-in, that all those get ran. So yeah, there's a lot of tests going on. Like sometimes they get deployed maybe 5 times a day. So
Anyone else? Well, that was Automated UI Tests. I'm Dylan Storing O'Dowd. Thank you for coming.